1.
In this video, we shall discuss the conversion of galvanometer to ammeter. What is a galvanometer? A galvanometer is a device that can be used to measure small current. A galvanometer is a device that can be used to measure small current. And it can also be called milliammeter, or microammeter, A galvanometer can also be called milliammeter or microammeter because the current that flows through a galvanometer is given in milliampere or microampere. The current that flows through a galvanometer is given in milliampere or microampere. That's why galvanometer can be called milliammeter or microammeter. Then what is an ammeter? An ammeter is a device that can be used to measure electric current. Ammeter is a device that can be used to measure electric current. And the ammeter can be connected in series in electrical circuit to appliances. Ammeter can be connected in series in an electrical circuit to appliances. For you to convert galvanometer to an ammeter, for you to convert a galvanometer to an ammeter, what we need a low resistance wire. A low resistance wire is needed for conversion of galvanometer to ammeter. The low resistance wire is known as shunt. A shunt is needed. A shunt is needed to convert galvanometer to an ammeter. And the shunt must be connected in parallel to a galvanometer. To convert galvanometer to an ammeter, a shunt is needed, which is a low resistance wire, which must be connected in parallel to a galvanometer. When you have a galvanometer, for this galvanometer to be converted to an ammeter, a shunt is needed, which is a low resistance wire. A shunt is needed. That means a shunt, a low resistance wire, which is known as shunt. RX, that means low resistance wire, shunt is needed for galvanometer to be converted to ammeter. And the shunt must be connected in parallel to the galvanometer. When you have a current from a source, a current is coming from a source, the current that flows through the galvanometer is known as a minute current, a small current that is given in what? IG. That is current that flows through the galvanometer. Don't forget that a galvanometer has a resistance, which is called a resistance of galvanometer. Resistance of galvanometer is given as what? RG. It has a resistance which is known as what? Resistance of a galvanometer, which is given as what? RG. Then you have a current from a source. At this point, the current that flows through the galvanometer is minute, it's micro, it's mini, which is known as what? IG. It flows through the galvanometer. Therefore, to calculate the current that flows through the what? Shunt. This current that flows through the galvanometer will be taken away from the total current, which is I. That means the current that flows through the shunt will be given as what? The current, the total current, minus the current of the galvanometer. Let us assume the total current is what? 10 ampere. 10 ampere is coming from a source. Then the current that will flows through the what? Ammeter. Let us assume is what? 10 milliampere. 10 milliampere is flowing through the what? Galvanometer. The total current is 10 ampere, and the current flowing through the galvanometer is known as what? Is given as 10 milliampere. Then the current that will flows through the shunt that is converted in what? That is connected in parallel to the galvanometer is the total current, which is 10 ampere, minus the current in the galvanometer, which is known as 10 milliampere. That means this is the current that will flows through the shunt. Is the current that will flows through the shunt. That means when you have the total current I coming from a source, the current that flows through the galvanometer, E, which is minute, is known as what? Current in the galvanometer. and the resistance of the galvanometer is given as what? Rg. Then for you to get the current that flows through the shunt, is known as what? The total current from the source minus the current in the galvanometer, which is Ig, is the current that flows through the shunt. Shunt is a low resistance wire that must be connected in parallel to a galvanometer for it to be converted to ammeter. Don't forget, from Ohm's law, what is Ohm's law? Ohm's law is what? V equal to IR. That is Ohm's law. Ohm's law. Ohm's law. It states that V equal to IR. Don't forget, when you have resistors connected in parallel, they have the same potential difference across them. When you have two or more resistors connected in parallel, they have the same potential difference across them. The resistance of the galvanometer and the resistance of the shunt, which are in parallel to each other. That means the resistance of the galvanometer and the resistance of the shunt, they have the same potential difference. I can simply say the potential difference of galvanometer equal to potential difference of shunt. That means from parallel connection of resistor, parallel connection of resistors, parallel connection of resistors, which says when two resistors or more resistors are connected in parallel, they have the same potential difference across them. That means these two resistors, that means the resistance of the galvanometer and the resistance of the shunt, are connected in parallel. That means the potential difference across the two is the same. And from Ohm's law, we have potential difference equal to current times resistance. I can simply say potential difference of galvanometer equal to potential difference of galvanometer. Since I know that this is current that flows through the galvanometer and this is resistance of the galvanometer, now this potential difference of the galvanometer with the current of the galvanometer multiplied by resistance in the galvanometer. While the resistance, the potential difference of the shunt, that means potential difference of the shunt will be current that flows through the shunt multiplied by the resistance of the shunt. That means current in the shunt, which is I minus Ig. Open bracket, I minus Ig, close the bracket, multiplied by resistance of the shunt. That means this is the potential difference of the shunt. And we know that potential difference of galvanometer is the same thing as potential difference of the shunt. Substitute this into this formula. From here, we have Vg, which is potential difference of the galvanometer. We have Ig, Rg equal to potential difference of the shunt, which is open bracket I minus Ig times resistance of the shunt. Make the resistance of the shunt the subject of the formula. We have resistance of the shunt equal to Ig, Rg into I minus Ig. This is the formula to calculate resistance of shunt. That is shunt. Whenever we need galvanometer in ammeter, whenever galvanometer must be converted to ammeter, the shunt is required, which is a low resistance wire, which must be connected in parallel. Then what is Ig? Ig is current of galvanometer, or current that flows through the galvanometer, which is given in milliampere. What is Rg? Rg is resistance of galvanometer. What is I? I is the total current. The total current given in ampere. What is Rs? Rs is